Okay, so let's do it. Okay, so are you ready? So let's begin our session. Let's begin our semester 3 live video. So as for the beginning of the chapters, so I'm going to uh, say hi to everybody. Very good evening. Hopefully you all will benefit from the videos that I've already prepared for you in live. So sorry for not able to respond to the live chats because okay, if you have any questions later, you may throw the comments and I'll try to reply the comments inside your video. So make sure that you put the timeline on how many minutes that you want to ask the questions, and then I will try to reply as fast as I can so that you'll be able to understand better. Okay, so without that session, let's begin our uh, lessons, shall we? So we are going to start off with the introductions to organic chemistry. So you may find the questions from the module which I sell online through Shopee. So if you have any inquiries, you can also ask your questions, ask your teachers to help you. So hopefully you all will be able to benefit from the videos in here. And without that session, let's do it. Okay. Okay, so we are going to start off with the answering for objective questions for organic chemistry. So starting from chapter 1, introductions of organic chemistry. So here are the questions. So here we go. Number 1, which of the following compound exhibit optical isomerism? So in here you have to know that what are the isomerisms that are exhibited in here. Mechanisms that are exhibited in here. Okay, so you have to find out on your own what are the isomerisms. Okay, so for example, the first one. Okay, so what are the isomerism that exhibit in the first one? So the first one we exhibited. Okay, the first one exhibited in here is a geometrical. Okay, so in here because you have a C double bond C. Okay, you have a C double bond C and surrounded by two different atoms and group of atom. So this will exhibit geometrical isomerism. Okay. As for number B, will be exhibited any stereoisomerism. So since you are surrounded by CH3, CH2, Cl, and Cl2 and CH3, but because this is Cl2, you have the same atom, so this will not exhibit optical isomerism. As for this one, we have a look at this carbon. So it is surrounded by CH2, CH2, CH3, then you have CH2, and then you have OH. This one also will not exhibit any optical isomerism. And as for C4, as for D, it is surrounded by CH2, CH3, H, OH, and then CH3. So we have four different surrounding atoms. So this will make this carbon a chiral carbon atom, hence exhibited geometrical isomerism. So the answer for question number 1 is donkey D. Okay, then we go to question number 2. Chlorine is used to make hexachlorophene, a type of chemical mouthwash to kill bacteria. Structural formula of hexachlorophene is shown below. Which of the following statement now? Please be careful with the terms not true. If you have a highlighter, you highlight it because we want not true regarding to the hexachlorophene. Okay, so number 1. It exhibited optical isomerism. Does it exhibited optical isomerism? So you have to know by yourself because carbon inside the benzene ring are all sp2 hybridized. So sp2 hybridized carbon cannot exhibit optical isomerism. So this is the only sp3 hybrid atom. But in here you see it is surrounded by two similar atoms, so it will not exhibit optical isomerism. So this statement is not true. When it is not true, then A is correct. Okay. Okay. Then for B, 1 mole of hexachlorophene contains 407 grams. So you have to calculate the relative molecular mass. But before you calculate the relative molecular mass, you have to deduce what is the molecular formula. So this is automatically C on its own. Okay. And inside a skeletal structure, please, because in skeletal structure we do not show hydrogen, so you must know by yourself that this is a hydrogen and this is a hydrogen inside the benzene ring. So as the result, what is the formula for this one? The formula in here is C13H6O2Cl6. So the relative molecular mass in here is 407, which is true. Okay, so when it is true, B is not our answer. Okay, and then C, 73.2 decimeter cube of chlorine gas is required to produce 1 mole of hexachlorophene. So if you can see in here, 1 hexachlorophene contains 6 chlorine atoms. Okay, so when you have 6 chlorine atoms, that means it came from 3 molecules of the chlorine. So therefore, the C is also true in here. And finally, complete combustion of 1 mole of hexachlorophene will yield 317 decimeter cube of carbon dioxide. Since one hexachlorophene produces 13 mole of carbon dioxide, so the volume in here is 24.4 times 13, you get 317, which is also true. So we are looking for not true, so the answer in here is A. Okay. Okay, so this is for question number 2. As for question number 3, compound A undergo catalytic hydrogenation according to the equation A plus H2 give AH2. Okay, given that AH2 is a trigonal planar, so AH2 is trigonal planar. Okay. If trigonal planar, that means this is a sp2 hybridized. This is after hydrogenation, you have sp2 hybridized. So when after hydrogenation, you have sp2, so originally it will comes from the sp molecule. Okay, so sp is usually popular for triple bond, while trigonal planar sp2 is for double bond. So before becoming trigonal planar, it is suggested that A can have a triple bond. So the best answer in here will be B. Okay. So you have to know by yourself what is the structure that may possibly form from the shapes that is given to you. Okay, so try to understand. Okay, so that is for question number 3. And then number 4, which of the following does not exhibit stereoisomerism? So in stereoisomerism, we have a look one by one at our choices. So first of all, we have A, but2-in, because it contains C double bond C, okay, which might shows geometrical. And then you see they are surrounded by 2 different atoms. So when they are surrounded by 2 different atoms, okay, that means that it is able to form a geometrical isomerism. Okay. As for B, B is we have to find chiral carbon atom. So if you look at the 3rd carbon in here, so it is surrounded by CH3, CH2, and then H, and then Cl, and then after that is surrounded by CH3. It is surrounded by 4 different atoms, therefore exhibit optical isomerism. Okay. As for C in here, in the cycloalkene, because this is a sp2 hybridized, okay, this is a sp2 hybridized, so it cannot exhibit geometrical because here don't have hydrogen anymore. And in terms of optical also it cannot. Okay, so in here, C does not have any stereoisomerism. As for D, D can exhibit geometrical isomerisms in here. So because in here you have H and H, so it can exhibit as a geometrical isomerism. Okay, so now can this one exhibited optical isomerisms or not? So they cannot exhibit optical isomerism. So how to eventually tell whether you can exhibited optical isomerisms or not in the structure? The technique is, imagine if you fold this into half. Okay, so if both sides are superimposable, that means it is not it does not have a chiral carbon atom lah. Okay, so therefore it cannot exhibit optical isomerism, but still it can exhibit geometrical, so therefore it's considered as a stereo isomerism. Okay, so the best answer in here is C. So that is for number 4. Then we go to number 5. Carbon-carbon bond length in ethane and ethene. Sorry, this one's supposed to be ethene. Sorry, ethene. Okay, and ethane is 0.134 and 0.154 nanometer respectively. Which of the following could be true regarding to carbon bond length inside a benzene? So you have to understand by yourself, in the benzene, you have an alternate double bond, single bond, such as like this. Okay, so but it exists, Kekuli structure deduced that benzene has a resonance structure which looks like this. So you can see when they are alternating between one to another, the C double bond and single bond keep on alternating in each other. Therefore, the bond length should be somewhere in between double bond and also single bond. Okay, should be somewhere alternating between double bond and single bond. Therefore, they will have all of them the same length, which is in between double bond and single bond, and therefore 143 nanometer. Okay, so the best answer for number 5 is boy B. Number 6, limonene is an essential oil found in the skin of lemon and orange. Its structure is given below. Which of the following is not true regarding limonene? We are looking for not true. Please highlight again. Okay, so which of the following is not true? So number 1, can it exhibit optical isomerism or not? Yes, it can exhibit optical isomerism because in here you have sp3 hybridized carbon. Okay, and it is surrounded by 4 different atoms, so it can still exhibit optical isomerism. B, can it exhibit geometrical isomerism? Yes, it can. It exhibits as a geometrical isomerism because it is surrounded by 2 different types of the atoms or group of atoms in here. So it can also exhibit geometrical isomerism. Is it insoluble in water? Now, usually for hydrocarbon, if you have somewhere in between, if it is because it is mostly made of carbon and hydrogen, it cannot form hydrogen bond. Therefore, it is not soluble in water. Therefore, the statement C, insoluble in water, is also true. And in terms of molecular mass is 136. If you calculate properly, okay, so this is a CH2, this is also CH2, okay, CH2 and CH2. So the total molecular formula in here is C10H18, hence 138. So it's not 136. Okay, so therefore the molecular mass is 138. Therefore D is not true. So the best answer in here is donkey D. Okay, so this is for number 6. Okay, as for number 7, an aqueous solution of propane diuric acid contains C3H6O2, C3H5O2-, C3H4O22-, H3O+, and H2O with different concentration. Which of the following species is the strongest base? Now, because propane diuric acid is a diproctic acid, and it will undergo stages of dissociation. This one you should know by yourself because in semester 1 you already learned that that polyprotic acid undergoes different stages of dissociation. And then also you should know in semester 1 we learn about the strength of acid base. So that means if you have a weak acid, such as for example C3H6O2 is a weak acid, isn't it? So when you have a weak acid, the conjugate base is a strong conjugate base. And in the second stage of the dissociation, okay, where C3H5O2, which is already weak, when you have a stronger conjugate base, conversely, it is a weaker Bronsted lauric acid. When weaker Bronsted lauric acid were to dissociate with another water, this is water, to dissociate another hydrogen ion, so a weaker Bronsted lauric acid will produce a stronger conjugate base. So therefore, as a result, C3H4O2 is to say the strongest conjugate base among all of the species that is present inside here. Okay, so therefore, the best answer for question number 7 will be C. So this is how we are going to deduce which species is the most strongest base. Okay, as for question number 8, 240 centimeter cube of gaseous hydrocarbon burns completely to produce 720 centimeter cube of carbon dioxide and 0.72 gram of water. Which of the following is the molecular formula of the hydrocarbon? So all gas are measured in which 1 decimeter cube occupy 24 centimeter cube. So first of all, you have to get the mole ratio for the hydrocarbon compared to carbon dioxide compared to water. So you use the general formula CXHY plus MO2 give XCO2 plus Y over 2 H2O. So you use the mole to solve for this. Since in here 240 centimeter cube of the hydrocarbon produces 720 centimeter cube of carbon dioxide, so the ratio of the hydrocarbon to carbon dioxide in here is 1 to 3. Therefore, it means that this hydrocarbon contains 3 carbons. Okay, whereas 0.72 gram of water, so you calculate the mole, so 0.072 divided by 18, you get 0.004. So since y over 2, in here is y over 2, isn't it? So since y over 2 is equals to 4, therefore y is equals to 8. That means hydrogen has 8. So as a result, the answer for this hydrocarbon will be something with 3 carbon and 8 hydrogen. So the best answer for this question is donkey D. Okay, so this is question number 8. So we go to the next one, which is question number 9. When 10 centimeter cube of gaseous organic compound B is completely burned with excess oxygen, 30 centimeter cube of carbon dioxide and 5 centimeter cube of nitrogen gas and water are formed. B could be what? So in here, they only give you the information of the volume of organic compound, the volume of the carbon dioxide, and the volume of the nitrogen gas. So you can deduce what is the possible structure based on the carbon and nitrogen alone. So if you calculate accordingly, let's say if it burns, you form carbon dioxide and water and nitrogen gas. Okay, so you compare the mole ratio in here. So the mole ratio of the hydrocarbons to the carbon dioxide and nitrogen is 10 centimeter cube to 30 centimeter cube to 5 centimeter cube. Hence, the simplest ratio is 1 to 3 to half. So half here is referred to half nitrogen, and half nitrogen is equivalent to 1 nitrogen. Therefore, in this organic compound, you shall have 3 carbon, 1 nitrogen. So inside here, as long as the A, B, 1, 2, 3, 4 in here, will contain 3 hydrogen, 1 nitrogen, it could be our answer. So which one is our answer? So since in number 1, you have 3 carbon, 1 nitrogen, so 1 is correct. In number 2, you have 3 carbon, 1 nitrogen, so 2 is also correct. In number 3, you have 3 carbon, 2 nitrogen, so number 3 is wrong. And in number 4, you have 3 carbon, 1 nitrogen, so 4 is also correct. So the best answer in here is 1, 2, and 4. Boy. Okay, so that is for number 9. As for number 10, which of the following alkene produces 0.264 gram of carbon dioxide and 0.99 gram of water after complete combustion? So let's together find out what is the ratio of the carbon dioxide and water. That means we can find out eventually what is the ratio of C to N, and then based on the empirical formula, you can try your best to deduce which is the possible structure of the substance. Okay, so in here, mole ratio of the carbon dioxide to water, so you divide it by their mass. So 0.264 divided by 44 to 0.99 divided by 18. So you get 0.06 to 0.095. So since stoichiometrically, H2O is to 1 9 over 2 ma. So Y here is 0.055 times 2. So therefore, the ratio of the carbon to hydrogen will be 6 to 11. So as long as inside this 1, 2, 3, 4, the ratio is 6 to 11 in terms of empirical formula, then it will be your answer. So let's find out together one by one what is the simplest ratio for each of them. So it seems like for number 1, okay, so for number 1, the formula in here is C6H10. So the ratio is 3 to 5. So 1 is wrong. In number 2, if you calculate properly, it is C12H22. Okay, C12H22. Okay, so in C12H22, it makes the ratio is 6 to 11. Therefore, 2 is correct. Number 3, also the same. Since the ratio is C12H22, the ratio is 6 to 11. So number 3 is also correct. And finally, number 4, if you calculate properly, it is also C12H22. So the ratio is also 6 to 11. Therefore, the ratio is also correct. So 2, 3, and 4 are correct. Therefore, the best answer in here is donkey D. So that is how you solved for question number 10. Okay, immediately we go to question number 11. Bond angle of two hydroxyethylamine molecules are labeled as ABCD below. Which of the following is the arrangement of the bond angle in ascending order? Now, inside STPM chemistry, especially when it comes to organic, you must know by yourself that which molecule has lone pair electron and etc. things. So in here, you must know by yourself, oxygen, when you only have two covalent bond, it must always have two these lone pair electrons in here. Carbon 4 covalent bond, no electron, no lone pair electron. Carbon 4 covalent bond, no lone pair electron. Nitrogen 3 covalent bond, that means nitrogen also must have one lone pair electron. So because of the two lone pair electron inside oxygen, it makes the angle of the O in here to become 104.5. Okay, this carbon is sp3. Okay, so if it is sp3, so it's 109.5. This carbon is sp2, so if it is sp2, it's 120. And then this nitrogen in here, it has lone pair electrons, so it is 107. So what is the correct ascending order in the bond angle? We have A, D, B, and finally C. So the best answer in here is boy B. Okay, so that is for number 11. Okay, then we go to question number 12. Aspartame is an artificial sweetener which has the following structure as follows. Which of the following molecule is not found inside here? So in here you have to be very good in identifying what are the functioning group present in the molecule. Okay, so aspartame, this one is a carboxyl group. Okay, we call this as a carboxyl. Okay, then this CONH, CONH, you must know by yourself that this is an amide. Okay, and then this one you must know by yourself that is aromatic. Okay, and then you have a COOCH3. Okay, so this is ester. Okay, and then because you have NH2 and COH, now this is the base from the amino acid lah. So amino acid is also part of the functioning group inside here. So which one is not inside our selection? Ester, yes. Amino acid, yes. Carboxyl, yes. Carbonyl, not yes, not true. So the best answer in here is donkey D. Okay. So in here you must be very good in identifying what are the functioning groups present in here. Okay. Okay. So that is for number 12. Okay, number 13. Which pair has the same boiling point? Okay. So, how to identify whether they have the same melting point, boiling point? Okay. In a geometrical isomer, cis trans, okay. In cis trans, you do not have this same physical properties due to the arrangement inside the plane, inside the planing here. So therefore, they are going to have different physical properties, hence different melting point, boiling point. So A is not going to be true because of the cis-trans structure. As for B, B is, even though they are isomer, because this is a straight chain, while this one is a branch chain. So they have different total surface area. So when they have different total surface area, so they are going to have a different physical property. So B is also not true. And then for C, C are pair of optical isomerism. So in pair of optical, they will not affect the arrangement inside. They just arrange in a different plane polarized light. Therefore, it will not affect the physical properties. Therefore, it can be correct. And then for D, the position of the chlorine, whether they are close or far, will also sometimes influence the physical properties in here. So it can also changes the physical properties. So the best answer in here will be C. Okay. Okay, so that is for question number 13. Huh? Okay, as for 14, one of the molecule of 1 mole of organic compound E react with 2 mole of hydrogen with a general formula CnH2n. What could be E? So in here, it says that 1 mole of organic compound E react with 2 mole of the hydrogen to form a molecule with the general formula CnH2n. Okay, so which one could be E? So when you have CnH2n, there are two possibilities. Either it is an alkene or it is a cycloalkane. Now, this one is after reacting with 2 hydrogen. So if you react with 2 hydrogen, that means you must have either a C triple bond C, one of them, and then E I refer to E must have a C triple bond C, or you have something with 2 double bond. Okay, okay, you must have a diene inside here. Okay. So the most important thing is at the end of the day, you give alkene or cycloalkane. Okay, so based on the selections in here, A, B, C, D, we deduce the possible. So this one, when you react with 2 hydrogen, so eventually this one will form H, this one will form H, isn't it? So when you react with 2 hydrogen, all of them become sp3 hybridized. So it is not important, it will become alkane in another word. Okay, so it will not be cycloalkane or alkene. So A is wrong. As for B, B after react with hydrogen, it forms it forms alkane. Okay, after you react with 2 hydrogen, you form alkane, isn't it? So alkane cannot be CnH2n. Alkane is CnH2n plus 2. As for C, after you react with 2 hydrogen, it becomes a cycloalkane. So when you become a cycloalkane, then it is still CnH2n. So C could be the answer. And then for D, this one is a cycloalkane, okay? But at the end, you react with another triple bond. So in here, you only react with 2 hydrogen. So let's say if this one reacted, but this one does not, okay? So it still forms cycloalkene, okay? It forms cycloalkene. So therefore, cycloalkene is not CnH2n. Cycloalkene is CnH2n minus 2. So that is why in here, D cannot be the answer. So our best answer is still C, okay? Okay, so that is for question number 14. So you must be very careful on the way of how you look at your answer inside here. Okay. Okay, so that is for number 14. Immediately we go to number 15. Jasmine extract from the pyritum flower and used as the insecticide. The structure of jasmine is as follows. So how many chiral carbon atoms are in this molecule? So let's together identify which one is a chiral carbon atom. Okay, so since this one is surrounded by 4, especially cycloalkane. The cycloalkane can easily exhibit optical. So since it has surrounded by 4 different group of atoms in here. Okay, so this one is a chiral carbon atom 1. Okay, this one also is a chiral carbon atom because this one is not. Sorry, this one is not. Because it is surrounded by 2 CH3. So when you are surrounded by 2 CH3, it is not a chiral carbon atom. And then this one is a chiral carbon atom. Okay, because it is surrounded by 4 different carbon. So there are 2. And then this one is surrounded by 4 different. So in here, it is different group. We consider this one as different group. So it is surrounded by different chiral carbon atoms. So 3. So this one also surrounded by different chiral carbon atoms. So 4. And finally, this one also surrounded by 4 different chiral carbon atoms. So 5. So you have altogether 5 chiral carbon atom. So therefore, the answer will be donkey D. Okay, so this is number 15. And then number 16, naphthalene C10H8 is an active component in mothball. Its structural formula is shown below. How many sigma bonds are there in the molecule? So inside skeletal structure, they will not show you whether you have hydrogen or not. So you must be very good by yourself to see whether they are hydrogen molecule or not. So showing to you here right now is what happened after I draw them in a full Lewis structure. So inside the full Lewis structure, this is how it looks like. So if you calculate how many sigma bond are there, they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So there are 19 sigma bonds inside here. So the answer in here is donkey D. Okay. Okay, so that is for number 16. As for 17, the pKa value of 4 organic species at 25 degrees Celsius are given in the table below. So based on the data given, which of the following statement is not true? Sometimes you have to be very careful because the questions can be tricky in the sense of true or not true, so you better highlight it. Okay, so we are looking for not true. Okay, so number 1, 4-nitroanilium is the most acidic species. So the most acidic will refer to the lowest pKa value. Okay. So the most acidic species is the lowest pKa. Most acidic means the lowest pKa. So it is the lowest pKa. Is it the lowest pKa inside here? So 4-nitro anilium ion is this one. Okay. So it is the most acidic. So this is correct because it has a 0.98. And then number B, 4-nitroaniline is the most stable species. So 4-nitroaniline is the most stable species means that if this one, after you donate the proton, okay, you give the 4-nitroaniline ion, okay, it's not longer ion, sorry, it's no longer ion, it's NH2. So this is 4-nitroaniline. So when you have the strongest acid, So when you have the strongest acid, it will give you the weakest conjugate base. It will give you the weakest conjugate base. And when you say that it has a weakest conjugate base, actually it is the most stable. Okay, it is the most stable in here. So that one is the most stable species. Okay. So number 2 is true. And then number 3, benzoate ion is more stable than 4-nitrobenzoate. So when you have this one, when you have, this is a stronger acid, isn't it? When this is a stronger acid, that means it is a weaker conjugate base. So the benzoate ion is more, when you have a weaker conjugate base, that means it is more stable lah. So when it is the more stable, so benzoate ion is more stable, this statement is not true. Okay. And then number 4, aniline is a weaker conjugate base than 4-nitroaniline. So because aniline is weaker acid. So weaker acid means that you have a stronger conjugate base. When you have a stronger conjugate base, that means this statement is also not true. Okay, so as a result, what is the answer in here? Okay, 4-nitroaniline is the most acid. This one is true. Okay, so it's 3 and 4 only. 3 and 4. Number 1 is true because it's the lowest pKa. Okay, so the answer is 3 and 4 only. So here, I do not have the answer in here. Sorry, the answer is 3 and 4 only. So number 1 is not. Number 1 is correct. Okay, number 1 is correct. Okay, so sorry for that. Okay, so number 17, the answer is 3 and 4 only. Okay, so that is for number 17. Okay, then we have question number 18. Ethene CH2 is polymerized to ethane under certain condition. What happened during this polymerization? So you must know by yourself that when you have a C double bond C, so this is a sp2, isn't it? When you polymerize to become ethene, so it will become sp3, isn't it? Okay, so what happened during this polymerization? CC bond length become longer, which is correct, because from sp2 to sp3, it becomes single bond, it becomes longer, so which is correct. Number B, the number of pi bond increases. Since the double bond has decreases, so this one is not true. The hybridization changes from sp to sp3, which is wrong because it changes from sp2 to sp3, and the bond angle changes from 120 to 90, which is also wrong because yes, this one is 120, okay, but when it changed to sp3, it becomes 109. Okay, so the best answer in here is A. Okay, number 19. An organic liquid contains carbon, hydrogen, oxygen. Complete combustion of 16.5 gram of liquid gives 31.6 gram of carbon dioxide and 19.3 gram of water. So what is the empirical formula of the organic liquid? Now this is quite a tricky question, because you have to use the mass to mass concept to solve for this. Okay, so let's together find out on how to do. So in here you have to understand the basic concept lah. Okay, so we have the general equation CXHYO plus MO2 give XCO2 plus Y over 2 H2O. Okay, so oxygen in here is not playing an important role, so we just usually put an unknown M lah. Okay, in here you have to know by yourself that stoichiometrically, one carbon produces one carbon dioxide. Okay, So if it is changed to mass, that means you have 12 grams of carbon is to 44 grams of the carbon dioxide. So in here, at the end of the day, you produces 31.6 grams of the carbon dioxide. So how much is the original mass of the carbons in here? Okay, so after you calculate, you get your X is equals to 8.62 grams. In terms of oxygen, since 2 hydrogen give 1 water, so 2 grams of hydrogen give 18 grams of water. So in terms of mass ratio, so Y times 2 times 1 is equals to 19.3 divided by 18. So at the end of the day, your mass of the hydrogen in here is 2.14 grams. Now you have carbon, you have hydrogen, how to get oxygen? So you combine the combustion of this compound, that means the total mass is 16.5. So you minus the mass of carbon minus the mass of hydrogen, this will be the mass of oxygen, which is 5.74. So after you get the mass of carbon, hydrogen, and oxygen separately, then you do the empirical formula methods. Okay, so 8.62 divided by 12, 2.14 divided by 1, 5.74 divided by 16. So you get your simplest ratio of the carbon to hydrogen to oxygen will be 2 to 6 to 1. So this will give your empirical formula to be your answer C. C2H6O2. Okay, so that is for question number 19. Okay, then we goes to question number 20. Cortisone is an inflammatory agent. Its molecule has follow. What can cortisone act as? So in here you need to identify what is the functioning group inside the compound. So let's together identify one by one. Okay, we start from the highest one. Okay, so in here you have to know that this is a primary alcohol. Okay, then this one is carbonyl. Okay, this one is carbonyl. Okay, as for this one, because it's surrounded by 3 carbon, so this is a tertiary alcohol. Okay, again, this one is also a carbonyl, ketone, more specifically ketone. Okay, then you have this one is an alkene. Okay, and this one, because it's surrounded by 2 carbon, isn't it? This is a secondary alcohol. Okay, so cortisone can act as a what? So based on this one, so the best answer in here is A. Okay, so the alkene, tertiary alcohol, and ketone. Okay, so that is for number 20. Yeah. Then we goes to 21. What is the type of isomerism shows in here? So we have a look one by one. What are the isomerism shows in here? Okay, as for the first one, you can obviously see that because it is surrounded by it has a C double bond C. Okay, and then it is surrounded by 2 different atoms. So this is obviously a geometrical isomerism. Okay. And as for the second one, it is a sp3 hybridized surrounded by 4 different molecules. So this is the optical isomerism. And then for this one, now even though you have a C double bond C here, because they have the same surrounding atom, so it is not a geometrical. So why don't we move to here, this one? Okay, you have a H, you have a Br, you have a CH3, and then you have something behind here, which is a whole molecule in here. So they have 4 different surrounding. So this is a chiral carbon atom, and this will cause an optical isomerism. Okay, so the best in here will be geometrical, optical, optical. So the answer is donkey D. And finally, we go to the answer, final question for objective 22. The reaction between hydroxide ion and the organic compound Rx can be represented by the following equation. We have Rx plus OH minus if ROH plus X minus. So this is actually a substitution reaction, a substitution reaction. So which of the following statement is correct about OH? So in here you can see OH in here, because of the lone pair electron, okay, so it can act as what we so call as a Lewis base, a lone pair electron donor. Okay, so OH act as a Lewis base, and the moment that you attack this R here, so OH minus in here act as a nucleophile. Okay, it act as a nucleophile. So this one and OH minus in here, as I mentioned just now, this is a type of substitution reaction. So it is a substitution reaction. So 2, 3, and 4 are correct. Okay, so the answer is donkey D. Okay. Okay, so there I have for you all the objective question for chapter 1. So tomorrow we are going to continue with structure and essay, because chapter 1 nothing much to be asked. If you figure out more or less they are the same pattern. So I'm still trying to figure out to find more questions about introductions, though they could be quite limited. So if you want, you can go and find on your own from your reference books. So I think I'm going to end my live for semester 3 for today. So we shall continue tomorrow, shall we? Okay. So have a good day and see you all tomorrow's lesson. Okay. Goodbye.